Hi, my name is Anne, and today I will be talking about the St. Louis Arch, or the Gateway up to the west. Here's what we know about the arch. We know it is 630 feet tall and 630 feet wide. The observation deck is where visitors can look out and see the city and see everything. The observation deck is centered at the top of the arch, and it is 65 feet long and 7 feet wide. We will be looking at the arch as a 2D shape. Since we can see it as a parabola, we know the furthest point from the base, or the vertex. We can use vertex form as our base function. A will tell us the direction of our parabola, while h is the x value of our vertex, and k is the y value of our vertex. Then we can plug in points to x and y to solve everything else. So we have the equation y equals a times x minus h squared plus k. We know the vertex because at the middle of the arch it is 630 feet tall. So we can use the coordinates 0, 630 and plug these into our base equation to solve for a. We start by squaring 315 to get 99,225. Then we subtract 630 from both sides. Then we can divide 99,225 to get a by itself. And just reduce our fraction to get a equals -2 divided by 315. We can plug this into our equation, so our new equation will be y equals -2 divided by 315 times x minus 0 squared plus 630. This is our new equation that we will use to find other coordinates on our parabola. To find the furthest point inside the observation deck, we will divide 65 by 2 to get 1 point on each side of the parabola. By doing that, we get 32.5. We can plug this into our x value to find the y value. Whether we plug in positive or negative 32.5, we will get 623.29 as our y value. So if you are on either side of the furthest wall inside the observation deck, you will be 623.29 feet above the ground. So we will get 2 points to add to our graph to see where the observation sits on our parabola. We can check this by plugging our y value back in and making sure it equals the 623.29. And when you plug either negative or positive 32.5, we do get that same answer. To determine the horizontal coordinates the visitor would be at if they were 600 feet above the ground, we would plug 600 in as our y value to find the x value. We would start by subtracting 630 from both sides. I divided everything by -1 just to get rid of the negatives. Then I multiplied everything by 315 divided by 2, which is just the reciprocal of 2 divided by 315, to get 4,725 equals x squared. Now, to get rid of the x squared, you will square root each side, and when we square root each side, we have to add the plus or minus to make sure that we account for both of the points. So we will have 2 points or 2 locations that can be at if you're 600 feet off the ground. From our last problem, we know that at the furthest end of the observation deck, you are 623.29 feet above the ground. So at 600 feet above the ground, you would be outside of the observation deck. We can check this by plugging in either -68.7 or positive 68.7 into the equation to make sure that it equals the 600, which it does. This would be the graph of our arch. We can see where the observation deck ends and how 600 feet above the ground one be inside of the observation deck. Now answering a few questions about this assignment. This assignment was challenging at first to find which equations would work best, but once I figured out which equation to use, is very straightforward. And it really helped apply that we do use math and algebra in everyday use, and it's used on things that we wouldn't even think about, like the arch. This assignment did relate to a lot of the context that we've been covering in class, especially graphing and just plug and chug equations. I did enjoy this assignment and like the new perspective it has given me on how we can use algebra in our everyday life. Thank you for learning about the Gateway Arch with me.